The tiniest constellation of the earthly sky hides an incredible density of bright stars. For millennia, this shining celestial rhombus served as the main guide for great navigators. Next to it yawns the coal sack, a frightening dark nebula absorbing our galaxy's light. And inside hides the magnificent stellar jewel box, shining brightly with cosmic diamonds.
Today, we're going to take a deep dive into one of the most famous patterns in the night sky, the Southern Cross, or as it's formally known, Crux. Now, it may be the smallest of all the constellations, but don't let its size fool you. It is absolutely packed with fascinating science, deep history, and profound cultural meaning. So let's explore what makes this small collection of stars so incredibly important.
And this, right here, is the central paradox of the Southern Cross. In terms of sheer celestial real estate, it's tiny, the smallest of all 88 official constellations, covering just 68 square degrees. But its significance? It's enormous. For centuries, it's been a critical guide for navigators and a powerful emblem for entire nations. It's this incredible contrast, this tiny footprint with a massive impact that we're going to unpack.
So here's our roadmap. We'll start with an astrophysical portrait, looking at the stars themselves. Then we'll get into celestial mechanics and why its visibility has changed over time. From there, we'll cover its vital role in navigation and discovery. After that, we'll explore the rich tapestry of myths and culture surrounding it. And finally, we'll wrap up with a practical observer's guide, so you know how to find it yourself.
All right, first things first, let's get into the physics. When you look up at the Southern Cross, what are you actually seeing? We're going to dissect the stars, the nebulae, and the clusters that make this patch of sky, nestled in the heart of the Milky Way, so spectacular.
Here are the four principal stars, the pillars of the cross. Now notice the spectral types. 3 of them, Crux, Mimosa, and Crux, are B-type stars. That means they are young, massive, and intensely hot, burning with a brilliant blue-white light. But then you've got Crux. It's an M-type, a red giant. It's cooler, much older, and significantly closer to us. This diversity in one small asterism is truly remarkable.
Let's focus on Crux for a moment. To your eye, it's the brightest point in the constellation, but it's holding a secret. It's not one star, but a complex multiple star system. The light you see is the combined blaze of at least 2 massive blue stars, gravitationally bound and orbiting each other so tightly that they blur into a single point of light from our perspective, 320 light-years away.
And then we have Mimosa. This number, 27,000 Kelvin, represents its surface temperature. To put that into perspective, our own sun is a relatively cool 5,800 Kelvin. Mimosa is nearly 5 times hotter, a furnace of a star that makes it one of the most luminous stars in our night sky. It's also a fascinating variable star, which means it actually pulsates, subtly and rhythmically changing its brightness over time. Crux is the exception that makes the view so stunning. As a red giant, it's a star nearing the end of its life, having swelled up and cooled down. This gives it a deep, brilliant orange color. When you see it in the sky next to its hot blue neighbors, the color contrast is just breathtaking. And, as an added bonus, it's the nearest red giant star to our solar system. Now, nestled right beside the cross is one of the most famous dark nebulae in the sky, the coal sack. It looks like a great dark void, a hole punched through the starfields of the Milky Way. But it isn't empty space at all. It's the opposite. It's an immense, dense cloud of cold interstellar dust and gas, so thick that it completely obscures the light from the millions of stars glowing behind it. Near Mimosa, we find another treasure, the Jewel Box Cluster. The astronomer John Herschel described it perfectly as a casket of variously colored precious stones. It's a young open cluster of stars, all born from the same nebula. Because the more massive stars burn hotter and bluer, while less massive ones are cooler and more orange, you get this incredible assortment of stellar colors, all sparkling in one field of view. It's a stellar nursery on full display.
Okay, for our second section, let's move from what the cross is to where and when we can actually see it. As it turns out, your ability to view this constellation is entirely dependent on 2 things: your latitude on Earth and, more surprisingly, your place in human history.
Today, your view is determined by your latitude. For about 45% of the world's population, south of about 25 degrees north, the constellation is fully visible. From there, it's what we call circumpolar. It never sets below the horizon. But as you travel north, it sinks lower and lower, until for 40% of the globe, it's completely invisible. But here's the catch. This celestial map is not permanent. So why isn't it permanent? Well, it's because of something called axial precession. Think of the Earth like a spinning top that's slowly starting to wobble. That wobble traces out a huge circle in the sky over a period of about 26,000 years. This means the positions of the stars slowly drift. Back in 3000 BCE, ancient observers in Greece and Babylon could see the Southern Cross quite clearly. Today, it's completely lost to them below the horizon. But the cycle continues. In about 12,000 years, it will once again begin to grace the skies of the Northern Hemisphere.
Let's move to our third section, navigation. Given its brightness and distinctive shape, it's no surprise the Southern Cross became an indispensable tool for anyone venturing across the southern oceans. Its story is really the story of exploration and how this asterism was formally put on our celestial maps.
So how does it work? Well, the Northern Hemisphere has Polaris, the North Star, which sits almost directly on the North Celestial Pole. The South, however, doesn't have a convenient pole star, so navigators developed this ingenious method. You take the long axis of the cross, from Crux down through Crux, and extend that line out into space about 4.5 times its length. That point you land on is the South Celestial Pole. From there, you just drop a line to the horizon and you've found true south. It's a remarkably accurate trick that guided ships for centuries.
The history of its identity is fascinating. The ancient Greeks, including Ptolemy, didn't see it as a separate constellation at all. They cataloged its stars as part of the hind legs of Centaurus. Then, as we just discussed, precession caused it to sink below Europe's horizon, and for over 1,000 years, it was essentially lost to European memory. It wasn't until the great voyages of discovery in the 1500s that navigators like Amerigo Vespucci brought back detailed descriptions of it. Finally, in 1679, the astronomer Augustin Royer formally carved it out and designated it as its own constellation, Crux, the Cross.
Okay, for our fourth section, we're shifting gears from the physical to the metaphysical. This simple cross shape has served as a celestial canvas, inviting cultures from all over the world to project their most profound stories, myths, and beliefs onto the heavens.
In European tradition, particularly after its rediscovery, a powerful Christian narrative took hold. Some legends, even echoed by the poet Dante, suggested these were the stars seen by Adam and Eve from the Garden of Eden. Its gradual disappearance from northern skies, due to precession, was poetically interpreted as a symbol of humanity's expulsion from paradise, a celestial reminder of a lost ideal.
But in the Southern Hemisphere, where the constellation has always been a constant presence, the stories are far older and more varied. For many Aboriginal Australian cultures, the cross itself is just part of a much larger picture. They see the Coal Sack Nebula as the head of a great emu in the sky, with the stars of the cross marking part of its body. To Polynesian navigators, it wasn't a cross, but Te Punga, the anchor of the great canoe belonging to the demigod Maui. It's a beautiful illustration of how the same 4 stars can inspire radically different, yet equally meaningful interpretations. And that brings us to our final section. We've talked about the science, the mechanics, and the myths. Now let's bring it all back to Earth and talk about how you, the observer, can connect with this amazing constellation for yourself.
First, you can't overstate its modern cultural power. The Southern Cross is such a potent symbol of Southern identity that it's featured prominently on the national flags of 5 separate nations: Australia, New Zealand, Brazil, Papua New Guinea, and Samoa. It's a testament to its enduring significance.
So if you're in the right part of the world, how do you find it? The easiest way is to first look for 2 exceptionally bright stars nearby, Alpha and Beta Centauri. They're famously known as the pointers because they form a line that points directly to the top of the cross. Once you've found it, grab a pair of binoculars. Scan the area around it and you'll see that stark, inky blackness of the coal sack against the glowing river of the Milky Way. And if you have a small telescope, point it at the jewel box cluster. You won't be disappointed.
So in the end, the Southern Cross is so much more than a simple asterism. It's an astrophysical laboratory for studying stellar evolution. It's been a clock for telling time and a compass for navigating the globe. And perhaps most importantly, it has been a canvas for our species' greatest stories. It makes you wonder, as we continue to gaze upward, what new meanings and new discoveries will we find in it next?
Thank you, friends. Strive for understanding and become wiser. See you soon.